Hey everyone, it's that math magician. On this video, we're going to take a look at probability and we're going to focus in on decision charts. They are a great tool that is going to help us see all of the possible outcomes that we have when we're given a certain type of problem. So the best way to do this is just to jump into an example problem here with decision charts. So we're going to look at the problem where I want to create a 4-digit PIN from the numbers 1 through 8. Now, if anyone out there happens to have a debit card, you know that when you go to the ATM, you stick your debit card in, you have to put in a 4-digit PIN. Now, has it ever come across your mind about, well, how many PINs are there, right? I mean, I have my own PIN for my debit card. I'm sure you have your own PIN. And what's the chance of those actually matching up? How many different possibilities are there for a 4-digit PIN? Well, we're going to kind of change it, though, for this problem because we're only going to pick from the numbers 1 through 8. We're not going to include 9. We're not going to include 0. We're just looking at those 8 numbers, 1 through 8. So this is where a decision chart is going to help us out. Now, we have to first, though, before we jump into this problem, decide, are we going to allow a number to repeat or are we not going to allow a number to repeat? For example, if I'm thinking of a 4-digit PIN, could my PIN look like this, 3432, right? Notice that there's a 3 twice in there. Are we going to say that it's possible to have a number repeat, or are we not going to let a number repeat? And I would say for this first example here, let's allow repeating. I'm going to write with repeat. So we're going to say that you can repeat a number in our 4-digit PIN. Now, here's where the decision chart comes in. We have 4 digits in our PIN. I'm going to write that out. This is your decision chart right there. I have my first number, my second digit, my third digit, and then our final 4th number. And what the decision chart does is you just write in the numbers or the number of possibilities for each part of that PIN. So for example, I'm looking at that first digit, right? The first digit of my 4-digit PIN. We want to write right here, how many numbers can I choose from in this set for this problem that we're looking at? And remember, we were told that we're choosing from the numbers 1 through 8. So that means then that I'm going to have 8 different possibilities for my first number. Think I can pick 1, 2, 3, 4, 5, 6, 7, or 8 to go into that first slot there. And now when we get to the second digit, we want to have to, again, make our decision. How many numbers can I pull from for this second number? And I think that it's still going to be 8, right? Because I said I can repeat a number. We're allowing repetition. So if I allow that to happen, then that means that I'm still picking from those same 8 numbers. What's really nice is that when we allow repetition, what happens is each decision for each digit there is going to have the same number of possibilities. It's all going to be 8 because we're choosing from those same 8 numbers and we're allowing us to repeat a digit. So now that we have our 4 8s there, the last step that we have to do is take those 4 8s and we need to multiply them. So we're going to do 8 times 8 times 8 times 8, which is really just 8 to the 4th power. And now we get our calculator out and we're going to type in 8 to the, 8 to the 4th power. And we see that the total possible combinations for our 4-digit PIN is going to be 4,096. That is a lot of different PINs when we allow repetition to happen. Okay. All right. So now I think what might be helpful for us is what happens when we don't allow repetition. What if I write here for my next one, I say without repetition? I'm not going to allow us to repeat a number, which means, again, think about it. That first number that I came up with, 3432, this is not going to be allowed now, right? Because that has a repeating digit. We're no longer going to have repetition allowed. So that number there, 4,096, is probably going to go lower, right? It's going to go lower because in there, we have lots of possibilities where numbers are repeating. You know what's in there? The number 1111. Also, 2222, right? We need to now remove all of those possibilities. And it might sound more difficult than it actually is because all we have to do is, again, create our decision chart. We're choosing from 4 digits. So there's my first, my second, my third, and my 4th. Again, that first digit, I believe that we are still choosing from those 8 numbers, right? I have 8 possibilities to choose from for that first digit. But now we have to think about it. I am not allowing repetition. Okay, we cannot repeat a number. So what's really happening is 1 through 8, these are the numbers from 1 through 8, right? Imagine that I'm picking that first number for that first digit of my PIN. Once I pick a number, I cannot choose it again. Let's say, for example, that number was, 6. Now I can't choose 6 again, right? 6 is no longer an option when I'm not allowing repetition. So when I get to my second digit here, how many possibilities am I going to have? It's no longer going to be 8 because right up there, I've crossed out that 6. So now I only have 1, 2, 3, 4, 5, 6, 7 possibilities to choose from because I've eliminated one of those possibilities. And you'll notice that when I get to the third number now, I've chosen a second number. Maybe I chose the 7. Now I'm only left with 6 numbers to choose from. And you probably can figure out if I pick that third number, I only have 5 left. This is a different problem than the one we saw originally, right? When you're repeating, notice that all of the numbers on that decision chart are the same. 8 times 8 times 8 times 8, because you can pick any number of times. But now I'm not repeating. So every time I pick a number, my numbers that I'm choosing from are going to keep going down by 1. So I end up with 8 times 7 times 6 times 5. And that right there, we can totally simplify because that's just going to be 8 times 7 times 6 times 5. Probably want to get our calculator out now and type that in. 8, whoops, I still have the old one in. 8 times 7 times 6 times 5. And we see that number has decreased now to 1,680 choices, right? Well, hopefully we're seeing that this number should always be less than when we allow repeating. When we allow repeating, we have a lot more options to choose from. When I take out repetition, that number is going to decrease because a number can't show up more than once. Okay, I hope that's starting to make a little sense for you. Let's go ahead and see one more example where hopefully it kind of clears that up for you. And we're going to show a brand new example problem here with trying to create a schedule with 6 classes. Think about the school you're at, middle school, high school, maybe even college, right? You have a schedule and you want to think about how you're going to set that schedule if I have to have 6 classes. Well, 6 classes means that our decision chart is going to grow. No longer am I just going to have 4 here. I'm going to need to have 6 because I have my first period, second period, third, fourth, fifth, and sixth period. Let's say for this first one, we're going to say that you can repeat a class, which doesn't actually make sense if you think about it, right? Think about your school set schedule. Think about the math class that you're in. Maybe you have a geometry class, right? If you have geometry first period, can you really have geometry sixth period? I don't think that really makes sense, right? When you have your school schedule, there's normally no repetition with classes. Usually you pick the class, it shows up once, it's not going to show up anywhere else in your schedule. But for this example, let's say that it is possible. I don't know who the heck would want this schedule, but what if you did end up with a school schedule where you had geometry every single period? We're going to say it's possible with this first part where repetition can happen. Now, in a real world situation, I don't think that's going to happen, but let's say it does here. So let's start working through this problem. We have 6 classes to choose from for first period, so now I'm going to write a 6 there. Second period comes along. I'm still going to have 6 periods to choose from, 6 classes to choose from, because we're not taking out an option. Okay, we're saying you can repeat a class. When there is repetition, what happens on our decision chart is all of those numbers end up being exactly the same. And this is going to equal 6 to the 6th power, because there are 6 classes that we're choosing out of 6 periods. You better get that calculator out and let's type in 6 to the 6th power. And we see that, whoa, if we allow repetition, those school counselors have a lot of work on their hands because there's going to be 46,656 different ways that you could create your school schedule, right? If you allow repetition. But as I said earlier, normally we do not allow repetition. You cannot repeat a class, okay? Normally, if you have first period as geometry, you are not going to have geometry show up again because that just doesn't make sense. So we need to actually look at this in the lens of a real world application. And that's what we're going to do now, okay? There's my decision chart for my 6 classes, okay? My first period class. Out of the 6 classes I need to take, I have 6 to choose from, right? Let's say that for my first period, geometry gets chosen. Now when I get to my second period class, geometry is no longer an option, right? Out of those 6 classes, I've already chosen one. So the number of classes that I can pick now is going to drop to 5 because I've taken one out. One's already been selected for first period. So again, still with that same train of thought, right? I get to third period. I no longer have 5 classes to choose from. I just picked one for my second period. So that means for my third period class, I'm only going to have 4 different classes to choose from. When you take out repeating, you don't allow repetition, what happens is each number is going to keep decreasing as you make a choice. Because every time you make a choice, you're taking one of those options out of the pool of options that you have, okay? So again, take those numbers, 6 times 5 times 4 times 3 times 2 times 1, and we better get our calculator out for this guy. And we're going to see that that number, 46,000, is going to drop. It's going to drop because we're not allowing repetition. So let's punch that in. 6 times 5 times 4 times 3 times 2 times 1. And wow. Out of those 46,000 choices we had, when we had repetition, the only ones where a class doesn't repeat, there's only 720 options. Okay? This is how decision charts can help you out with problems like this, where I'm trying to pick a certain number of things to happen and I'm pulling from a certain set of numbers. We see it with our school schedule here. I got 6 classes. I made 6 lines here. For my decision chart, you just put in the number of options that you have, okay? Same up here with our 4-digit PIN. I had 4 digits I'm picking, so I made 4 lines here for my decision chart. And then on top, we just put in the numbers that we're pulling from, okay? Multiply them and you'll get that answer every single time. It's that Math Magician, and I'll see you on the next video.